where we left off yesterday. We were ready for example B on the back. And if you recall by looking back at the front, we are working with the side-side angle situation. Okay, so here we have triangle ABC, given that side A is 6, side B is 7, and angle A is 30 degrees. Now, as we look at this situation, and I think I'm going to go ahead and draw now. I will say B is the problem I have lots to fit in, so just kind of be aware as you're doing your spacing. C, there's probably more space available, but I'll have a lot less to write. So, okay, so my triangle ABC, I'm going to draw something like this. Okay? And I'm going to start with my angle A over here at the left corner. And we're provided that angle A is 30 degrees, yes?
Yep.
We know that side A is opposite and it's 6. And if we're going based on what kind of looks right, side B is about the same length. So I'm going to put side B over here as 7. Now, while we're here, I mean, I've kind of already told you what section we're in. But first of all, confirm what type of triangle is this? This is a side-side angle, yes? Well, as you look at this side-side angle, what do you notice here? What? We are going to solve for B here in a moment. Okay, but if we go back to the previous page and do a quick comparison, maybe. Okay, we are at angle A is acute, yes? Angle A is acute. Side A is smaller than the other side provided. So we are actually fitting into this middle scenario here. Okay, and I'm going to try and demonstrate that by attempting to draw a picture. I can show you a picture in the book, but we're actually going to be in a situation where there's going to be 2 triangles possible. Okay, I have the first triangle drawn. And then I think what I'll do is we'll go ahead and find that, information. And then I'll kind of explain how there can be another triangle. So with that in mind, I'm going to go ahead and label angle B. Then by process of elimination, these are angle C, correct? Okay, so let's go ahead and find what we can, which, Hannah, you already mentioned that the first thing we can find is angle B, right? We know our set of A information. We know half of our B information, so we can find the other half of B. So I'm going to set this up here as sine of A over A is going to be equal to sine of B over B. So what do we have here? Sine of 30 over 6 is equal to sine of B over 7. Okay. My recommendation is going to be to cross multiply. Can you cross multiply and divide all at once? Are we that fancy?
I'm not feeling it today.
You're not feeling it? Well,
Maybe.
I am feeling it.
so
Maybe
6
tomorrow.
times sine B is going to be equal to 7 times sine 30. If I go ahead and solve for sine B, we're going to have what? Sine B is going to be equal to 7 times sine of 30 divided by 6. I kind of put my 2 steps together there. Okay, recall from yesterday. What's my final step? How do I actually find B here? Okay. We know the output. We need to find the input. So we're going to use inverse function. So in order to find B, we're going to do sine inverse of 7 sine 30 degrees over 6.
I know, I was being slow. I was thinking. I think you guys should also know.
That's what I got.
35 points.
Now, do me a favor. Check. Make sure we know how to do this in the calculators. I know we had one like this yesterday, but it's important we know how to do this in the calculator. Of course, your calculator is in degree setting.
37, 35, 35.67.
Yes.
I have written down 35.7 degrees. Sounds like it comes up 35.67 on the calculator.
6'9".
Okay. So, with that in mind, we have angle B. What's next?
Angle C.
Angle C.
That's where I'm at.
How do we find angle C?
35.7 plus 30.
We can't find side C until we know angle C. How do we find angle C? It was, shoot, I didn't set this up very well, did I? Okay, I normally write some information up, use all this space up top, so I'm not going to be able to do that. So, okay, angle A plus angle B plus angle C equals 180, correct? With that information in hand, I'm not writing any more work. I'm trying to save space.
That's where I'm at.
Angle C is what?
114. Sorry.
I was even going to type this one right.
114.3 degrees. We know angle B, we know angle C. What's left to find?
Side C.
Side C. We can go back and use our law of sines. If we're trying to find side C, you can pick the A information or the B information. I personally am going to use A because it is the more specific information. There's nothing rounded in A. So I'm going to use sine of A over A is equal to sine of C over C. So sine of 30 degrees over 6 is equal to sine of 114.3 degrees
Over C.
over C. Cross products, right? And solve. So if I do my cross products, C times sine of 30 degrees equals 6 times sine of 114.3 degrees. If I go ahead and do the next step, then we're also going to go ahead and divide. So C is going to be 6 times sine of 114.3 degrees divided by sine of 30 degrees.
That's what I got.
Again, be practicing your calculators. Don't just let everyone else do the work and assume, oh, it'll be fine when I get to using the calculator.
Ten, 11.
Give me one decimal place.
10.9.
10.9.
10.9.
Okay. We're halfway done with this problem.
Oh.
Still got the other triangle.
Okay. This is a scenario where we have two possible triangles. So,
Alright, cool.
now, if you're saying you don't have room, here's the deal. C does not require a ton of room. So you can definitely work your way down to the side of C and you'll be fine. Okay? Let me change colors. Okay. The idea I said is there are two triangles, right? So we have this triangle with the provided information that A is 30, or A is 30 degrees, A is 6, and B is 7. So the idea is, I'm going to draw, let's see, how do I want to do this? I'm going to try and draw a partially dotted triangle there, because here's the deal. A is still 30 degrees, and side A is still 6, but what's going to happen is side A is going to swing over, and we're going to have a tiny little triangle here, is what's happening. Okay, and this can happen because that 6 is smaller than 7. Okay, so because we have this acute angle and the opposite side is smaller than the other provided side, We can have the normal, what I would call normal, big type triangle, or you can swing that A side under, and technically it should probably even be drawn a little skinnier than that, but I struggle to draw this triangle and make it look precise. Okay? Now, with that in mind, keep in mind, this distance out here was also originally 6, correct? It's no longer my official side of a triangle, but we kind of need that information to know what's what. So let me get some labels back on. Angle B is now going to be right down there. Angle C is still up there. Okay. If we go about our law of sines right now, and we throw in our 30 degrees, 6 and 7 into law of sines, what's B going to come out to be? That 35.7 there, isn't it? Is that what B is? Is B 35.7 in this triangle? No. Okay. So we have to think a little bit differently. And what we know from previous, in our previous triangle up above, that came up to be 35.7 degrees, yes? Okay. It's not drawn accurately. Never make this happen, but if you look, I'm trying to think, do I want to trace this or not? I'm going to trace this for a moment. I'm probably going to take the trace off. If you look at this triangle right here, I'm going to erase that blue here in a moment, okay? Because it's going to get to be too much. But if you look at that triangle right there, this angle is 35.7. This is not drawn to scale, but what do you notice about the two sides we know? This side is 6 here, and what was this side of my previous triangle? 6. If you have a side 6 and a side 6, how can that help me out with angles?
Transverse. That's not very good.
It's a nice isosceles triangle.
It's a nice isosceles triangle.
So two of the angles are going to be the same. Yeah.
So if 2 of the sides are the same, 2 of the angles are the same.
At the bottom angles, which means the left is 35.
So that'll-
So if this is 35.7, then this angle right here, are you seeing it?
would be 144.
Well, this angle right here is 35.7.
Yeah.
And then what are you doing to find what we actually need to know, Noah?
Do 180 subtracted from that angle.
Okay.
That's what I was trying to
Did
Elementary.
you say supplementary?
Yeah.
Okay.
I couldn't remember
Elementary, that was last
geometry.
year.
Well,
I was-
It
elementary.
started back in elementary and middle school.
Elementary, dear Watson.
Okay. Maybe I don't. Is it okay if I leave that blue on there? I think I might leave that on there. Okay, so in order to find our angle B in this triangle, we had to do 180 degrees minus the previous angle B. And 180 minus 35.7 is whatever I was already told.
144.
144.3 degrees. Now, we have a new angle B. We can find the rest of this triangle the same way we found the previous triangle.
Let's find angle C first.
We have to find angle C first. How do we find angle C?
144.
Still back to the same old thing that all three angles in a triangle are 180 degrees, yes? So angle A plus the new angle B plus angle C are going to equal 180 degrees. So you're still going back and using the 30 degrees, but now my B is 144.3. And you said 5.7?
Yeah.
Okay. So my new angle C on the second triangle is 5.7 degrees. And then we still need to find
Let's use
Sides.
side
sine A.
C.
Yeah.
And I would still go back and use our A information because that's still the provided information. That's still the solid, non-rounded information best to use with your new angle C. So I can still use the idea of sine of A over A is equal to sine of C over C. So sine of 30 degrees over 6 is equal to sine of 5.7 degrees over C. Cross products is going to have 6 times sine of 5.7 degrees, and then it's C times sine of 30 degrees. So to get C by itself, we're going to divide by sine of 30 degrees. And we're going to get some magical C value.
That's not bad. Did you get it?
What did you
What did we all get?
That's
I
what I
always
thought.
do.
1 point.
Okay.
Yes.
1 point,
So you were wrong.
1.19.
1.1918369.
Okay. I am indeed looking for C is 1.2.
Good job.
Okay.
Okay.
So now we have our second triangle.
I see what I did wrong.
Okay.
Indeed.
Okay. So this is a tricky one of dissection. Okay. So when you're asked to find two triangles, find the first triangle normally, and then to start the second triangle, this is going to be your key step right here, is knowing to do 180 minus the previous angle you found. Okay? Now, I will say in the book, and this is just kind of a side note, it's figure 5.19 on page 4 something or other, 429. So if you're struggling with seeing the Mrs. Sargent pictures that aren't drawn very well,
I think they're drawn great.
hey, it worked. I got you guys there. But there is a picture that helps to show it a little bit
It
better.
gets the job
Okay?
done.
Okay. Are we ready for C? Okay. C. Solve triangle ABC given that side A is 8, side B is 15, and angle A is 100 degrees. Okay? Like previous, I'm going to
Draw triangles.
sketch a triangle. Now, I'm given an obtuse angle here, so I'm going to sketch mine obtusely.
Is that a word?
It is now.
I'll have to ask other people.
So A is 100 degrees. We know that side A is 8. Side B is 15. Pick whichever one you want to make that. And that is our provided information.
I think if that method's allowed, we're going to take that disrespect.
Okay. Thoughts? What'd you say? Okay, if you're looking back on the other page, we're now looking at given the angle A is obtuse. Okay. What do you notice about this triangle?
You can find B.
We can find B. Not sure how it would work out, but we could try and find B. Somewhere we'd run into a glitch here.
Can't we find B?
You can find B. I just can't guarantee it would be accurate or work out well.
Why?
Huh?
Why wouldn't it work?
Yeah, why wouldn't it work?
Because you're
You tell me.
Mario's doing it.
That's not possible.
Why?
It's the
Did we have one triangle possible if
there's no triangles possible, so it's just no solution.
Why?
Where?
Because
Because
do
B
you
is
see
greater
that?
than A.
because A is greater than C. No, you can just tell. You can just look at it and know.
It's too
Oh, is this not the third? Okay. If A is obtuse, we have one triangle.
Okay. We are given an obtuse angle. Okay? When given an obtuse angle, what needs to be across from the obtuse angle?
Oh.
No, we're not talking right triangle. Forget the word hypotenuse.
Well,
The longest.
The longest side. How many obtuse angles can be in a triangle? Only one. This will be the biggest angle in the triangle. The biggest angle in the triangle has to be opposite the longest side. Is 8 the longest side? No.
the math is not easy.
Okay? It doesn't math. Okay? It doesn't math. And so the catch you have to look for. Now, if my A and B information had been switched, and they told us that A was 15 and B was 8, I'd be all about it. We'd be all over this. We'd be working the problem and done by now. Okay? But it's because, given an obtuse angle, that opposite side has to be the longest side. Okay, so, official answer is no triangle possible.
I get what you mean by not a lot of work.
Now, I am going to write an explanation in so that when you look back at this later and say, why didn't we just work it? How did we know? And that's because the obtuse angle must be opposite the longest side. Obtuse angle must be opposite the longest side. Okay? So what we needed is we needed A to be greater than B, and it was not. Okay.
Do we have to do the last two?
Yeah, I don't think that there's.
I want to do example 3.
Forest
Okay.
Ranger,
Tell
Chris
Forest
Jones.
I could be
Chris
sold.
Jones, Chris Jones.
Example 4, I could be sold on with or without. You know,
Perfect.
we have to
Depends
do
on how-
example. I definitely want to do example 3.
Chris Jones.
How is that for you?
Okay, you guys got what you need from this page?
Forest Ranger.
Okay. Example 3, Forest Ranger Chris Johnson at Ranger Station A sights a fire in the direction 32 degrees east of north. Ranger Rick Thorpe at Ranger Station B, 10 miles due east of A, sights the same fire on a line 48 degrees west of north. Find the distance from each ranger station to the fire.
That makes total sense.
I feel like it would have been more fitting if it was coordinated.
Tell the Rangers to jump
West.
Well, you know,
West. That's a fire community.
okay, guys. So, best thing we've got to do is draw a picture.
A picture.
Okay, we've got to have a picture on this one to make it all make sense. Now, an important part of this problem. Do you know your directions?
Yes.
Never eat soggy waffles.
Never eat shredded wheats.
I'll tell you
I'm
on
old.
your car.
I always just think about the U.S.
Stretch
That's
for east,
because
and that's like
that's the West.
That's the best kind. So,
And you
okay.
sour.
However you want to remember it, know your directions. You are juniors and seniors in high school. Know your directions.
I could not tell you at all where I'm going.
North
It says on your
So
car.
Kokomo's that way, Kokomo's
Yeah,
I know that.
Tifton's south.
Kokomo's more like
That's-
that way.
Okay,
I know that much.
That's why.
let's talk about the fire.
Illinois, Ohio.
Directly north.
Okay, so Ranger Chris Johnson at Station A.
I don't care.
So
What do you do like when your map says like, hey,
here is Station A. Okay, big and fancy, right?
station A.
Ranger Chris Johnson
We jump.
at Station A sights a fire in the direction 32 degrees east of north. So where is north on my paper? This is north, correct? Just kind of give you a bearing there. So 32 degrees east of north. Where is 32 degrees east of north going to be?
It's like that.
32 degrees to the right.
That is kind of a not. Okay. So what we're saying is he sights the fire 32 degrees east of north. Now, what is that 32 degrees? That is that angle right there. Okay?
Why couldn't they just say northeast?
We're just going with it. Now, Ranger Rick Thorpe at Ranger Station B, which is 10 miles due east of A. So where is Ranger Station B?
10 miles.
10 miles due east, which means
Oh, shoot.
There we go.
Fire.
The fire was up top.
Yeah.
We hadn't even talked about Station B now. B is 10 miles due east of A. And at his Ranger Station B, he sights the same fire on a line 48 degrees west of north. So north is still straight up on my paper. 48 degrees west of north means he's looking this way, and 48 degrees is that distance between north and how far west he's looking.
Oh, that's right.
Okay. Find the distance from each ranger station to the fire. So I'm being asked to find the distance from Ranger Station A to the fire, which I'm going to call little b. And I'm being asked to find the distance from Ranger Station B to the fire, which I'm going to call little a.
Oh, freaking.
So you don't have to know C at all.
Debatable. Let's keep going. Okay, so we need to find. Do you see why I labeled those sides A's and B's the way I did?
Yeah.
I was trying to pair them up with, here's angle A, so opposite angle A. Here's angle B, opposite angle B. Now, where do we go? What do we do from here?
Find the angles.
Find the angles, okay?
Subtract those from 90 for 2 degrees.
Okay, so the angles that we were given, the 32 degrees and 48 degrees, they are part of a right angle. So throw in the vocabulary word if you want, and they are complementary angles to another angle, right? So 90 minus 32 is, so that angle is going to be 58 degrees. 90 minus 48 is 42 degrees. I'm sorry, I'm not writing this incredibly difficult piece of the math down.
No.
Okay.
If you really want to know their angle, it's 80.
Okay.
You need to know.
She says if we really want the other
If
angle,
you really want it.
and why is the other one 80? All three angles in a triangle add up to be 180, yes? So we have 58 plus 42, which must add up to be 100. 180 minus 100 is 80. Okay. Now what? Find the sides. How are we going to find the sides?
Let's use C.
Because we don't have C.
Yeah, you do.
We have,
C's 10.
you have C to find the other
Oh,
ones.
C is good.
Here's the deal, guys. We know half of the A information, half of the B information. We have to use our C information. We know angle B is 42. We haven't found side B yet. We know angle A is 58. We haven't found side A yet. So I can't use A to find B or B to find A because I don't know the whole set of information. Not with law of sines. Okay, C, which I never labeled C, but Angle C is the 80 degrees of the fire. Side C is the 10 miles between the two ranger stations. So, thus I had to disagree. You do have to know C information here. Okay? And do the math. So, what? Sine of A over A is going to be equal to sine of C over C. The way I started mine off at least. So sine of 58 degrees over little a is going to equal sine of 80 degrees over 10.
Yep.
Little a is going to be equal to 10 times sine of 58 degrees divided by sine of 80 degrees. Take 2 steps to get there if you need to. Side A is what?
8.6.
I got 8.6.
And that is 8.6 what?
Miles.
Miles. And what is that?
Long.
Well, it's side A, but what is side A? Because side A was not part of the original problem. That was a name I came up with.
The distance from station B to the fire.
Okay, so that is the distance from station B to the fire. Yes? You understand that?
Ranger Rick.
So that is the distance from station B to the fire. I just want you to realize that's not the distance, because it's side A, it's not the distance from station A. Okay? Okay. Other half. Sine B over B, and I'm going to go back and continue to use my solid C information. Sine of 42 degrees over B is equal to sine of 80 degrees over 10. Cross products, B times sine of 80 degrees is equal to 10 times sine of 42 degrees. We're going to divide by the sine of 80 degrees. And B is
6.8.
6.8 miles. And that 6.8 miles is the distance from station A to the fire. Okay. Whenever you have something with directions involved, guys, you've got to draw that picture to see how it all goes together. Once you have a picture, this problem's incredibly easy, isn't it? I didn't have to really, tell you where to go on the problem or anything. It's an easy problem, but you have to get a valid picture there.
I've got a valid picture.
Okay. Example 4. You need the picture. Now, good news about example 4, if I'm recalling, is there's a nice picture in the book provided. And the one like this in homework also has a picture provided, which makes it 100% easier. Okay? If you read the problem, a road slopes 10 degrees above the horizontal and a vertical pole stand beside the road. The angle of elevation of the sun is 62 degrees and the pole casts a 14.5 foot shadow downhill along the road. Find the height of the telephone pole. This one, again, is very dependent on having a valid picture. The problem I have with this one is it's harder to visualize exactly what they mean by some of this. Maybe it's just me.
So the road.
Exactly.
I know. I'm trying to think.
Exactly.
The road is
so what
above?
exactly do they mean here?
It's
Is
above.
it like a whole situation?
That's. I know. The whole thing. The slope is what's.
Yeah, why is it?
But I think it's above.
Well, 10 degrees above.
Finding the height.
10 degrees above the horizontal is going to be this, and the vertical pole stands like that, and then the angle of the elevation of the
See, that
sun.
doesn't make even more sense.
Are we using a freaking
Oh,
sextant?
so then
Okay.
Extra light.
So there's your picture up on the screen, on the TV screen. Okay. The road slopes 10 degrees above the horizontal. So there's your horizontal. Your road is the solid line. Vertical telephone pole stands beside the road. the angle of elevation of the sun is 62 degrees, so that's 62 degrees coming down from above.
It's not sloping
The
upward.
pole cast a 14.5-foot shadow downhill along the road, which is not drawn in there. But 14.5-foot shadow, that's going to be, that's your shadow right there. Okay, so
that's
from A to
14
B
and
is your 14.5. And then find the height of the telephone pole.
Whoa.
Okay.
Okay.
How do we know the
As I
angle?
said,
It's just worded very odd.
it is, if you can figure out the picture, it's going to be an easy problem to do. The problem is
Very enough.
the wording, okay?
How do
And,
we
you know, now, I believe one of your last four, probably 38 or 39, is a problem like this. But here's the deal. Guess what's provided in the homework? The picture. Okay? So, if we use that picture up there, I don't even know if I want to.
We know the angle of the sun and not the height of the telephone.
You're trying to find it.
Yeah. How would you find the angle of the sun?
Okay, if I draw the important triangle here, there's A, there's B, there's C. Now, and this is, what page am I, this is in the book, right? This is page 431, figure 5.21. Just so you know. What did I say, 431, figure point 5.21. That's why you're only getting part of the picture, because you can look in the book just like I can, right? Now, we said the what? The shadow is right there. Okay. Find the height of the telephone pole, which is A. Okay, so the height of the telephone pole that we're looking for is A. What else do we need to know here? What'd you say? I think the other piece of information. Okay, and see, this is where probably should draw this road in, because we need to have the fact that this is 10 degrees right there. Okay. Now,
How does that help?
well, because we need to find some angles in here, right? And there's another angle up here that's 62, but right here we have this angle that is 10. This 10 is the horizontal, so the horizontal with the telephone pole is going to make a 90. So what does that make this angle here? 80. If that's 80, what's inside the triangle? 100. Okay? So that's part of the information you have to have. And then, and again, it's figuring out the picture that's difficult in this one. The one in homework is not nearly as bad. Okay, so don't just look at it and be like, oh, that's like the one I didn't understand in class. No, try and figure out the picture. And then the other information that I did not get drawn in. It's so hard to draw this all in. The 62 degrees here. Now, how do I want to explain this?
The vertical angle is 62.
But it's not a vertical angle.
It's
Well,
not a vertical angle.
I guess the vertical angle is going to be, if this is 62, are you talking about this?
Yeah.
Okay, okay.
Because I'm looking at that
Okay.
because that one's a little.
I know, no, you're fine. It is better.
So you can find
Okay.
360. You can subtract 62,
I wasn't going to do 360, but
and then you would be able to
No,
find
you
that
subtract.
angle. But then I don't know how to divide that.
You subtract.
how about if this is 62 and this is 62, think right angle right here.
Yeah.
90 minus 62
Oh.
is 28.
It's kind of annoying now.
And what's
128 from 180 is 52.
Woohoo, we got
Okay. Now, do we see paired up information, guys? We know 28 degrees is opposite 14.5 degrees. We're trying to find A. What is that opposite? 52 degrees. So if I forego the letters, the sine of 28 degrees over 14.5 is equal to the sine of 52 degrees over A. Okay? I'm going to skip the magical work and tell you that I have written down in my notes the answer is 24.3 feet. Okay? Okay. I've written down the homework is 2 through 12 evens, 20, 22, 38, and 39. Okay? Do the homework, attempt all problems for tomorrow, come back with questions. We'll check homework and start the new notes.
Have a good one.